Guys, there are so many roundabouts where I live. Like, I take 4 or 5 roundabouts just to get to work. And I hate driving, guys. But the roundabouts are fun. Oh, when I listen to music in the car, sometimes a song will play and I'm like, wow, I need to find a roundabout to drive on right now. The other day it was Cinderella by Rainbow Kitten Surprise. I love their new album. Let me know what music you guys like to drive to. I would love to know. Anyways, every time I'm going to work, I put my water bottle, and it's an Awala water bottle, so it doesn't fit in the cup holder. If you know, you know. So every time I go to work, I put my water bottle in the passenger seat. And by the time I hit that first roundabout, it goes flying. Honestly, I should buckle that thing in. Stop. That's actually really cute. I'm gonna buckle in my emotional support water bottle. So this actually happened the other day, and as I was driving through the rest of the roundabouts to get to work, I remembered that in high school physics, we talked about purses flying off car seats or something, and I think it was because of inertia or something like that. So I'm gonna Google it and a few other things because I have some bones to pick with physics. This has been on my mind for a while. Before we start Googling questions that would make my high school science teacher cringe, I would like to shout out my high school science teacher. Jarv, if you're watching this, I love you so much. You are a terrifying and inspiring role model and teacher, and I'm so sorry that I don't remember anything, and it's not your fault. I actually loved this teacher, you guys, and I was really interested in science as a kid because I loved learning about flowers growing and rain and clouds and butterflies, and everything was so fun. But then as I got into high school, we started learning about like human bodies and anatomy and chemistry. And so I was starting to get really scared of science, and I was starting to feel really over my head. But this teacher, Jarv, she never let me quit science. She kept my ass in her classroom seat, whether I liked it or not. And I love her for that, and I hope she knows that. Actually, I want to look up, that reminds me, I would love to look up what teaching techniques are best for ADHD. Because looking back, I wonder if my favorite teachers were the ones who did those techniques, whether they meant to or not. Let's see. 8 ADHD teaching techniques. Oh, and it's a kindergarten class. Love it. Every time I try to Google ADHD, it comes up with like children. Come on. What's this one? This is from Scott Shapiro, MD, adult ADD and ADHD, New York City psychiatrist. It was like the second thing that pulled up. So I'm gonna go with this one. Number 1, embrace learning style diversity. Oh, so this is talking about tailored teaching methods to engage all senses, because ADHD learners will be very visual, whereas other neurotypical learners will be very auditory. Since learning styles are so inconsistent, then you need to be able to include all of them to engage every single learner in that classroom. This is talking about hands-on activities and interactive experiences. Kinesthetic learners, those are the ones who really like hands-on activities. I think that's me. Sometimes charts are really hard for me to read. I always thought I was a visual learner, but like I can't even read a map. I think I'm a kinesthetic learner. And you know what? Right off the bat, Jarv, she really did that. She did a lot of hands-on activities. You know, she was one of the only classes that would do, what were they called? When you would give like a dead frog surgery. What is that called? When you give a dead, what is this? When you... It's on the tip of my tongue, but I just don't want to... Dissection. Yeah, I feel dumb. When you dissect a frog. Yeah, she would do a lot of dissections. I think in her classes, I dissected 5 or 6 animals, and there were a lot of interactive experiences. She did a lot of like computer software. She would experiment with that. Oh my God, I'm gonna cry. She knew exactly who she was teaching. She did such a good job with all of my siblings, and we all got a little something, a little bit of the tisms. She did engage all senses. You know, she helped visual learners with like diagrams and visual aids and study packets, but she also did student discussions and lectures for the auditory learners. And then for kinesthetic learners like me, she had those hands-on activities like dissections and projects or those interactive experiences online. Not only that, but she also did, I'm seeing number 3 here, is establish immediate relevance. Making the information immediately relevant to learners' lives is crucial for engagement and motivation. She always provided real-world examples, and she always would establish why this was important for us to know. Oh, I remember we were doing this lizard lesson where these lizards lost their tails. And that was one of those online softwares that she was experimenting with. And that was a lot of fun because it was teaching us about adaptation and why that was important to us, and it is affecting us. So she was also really good at that. I've always been one of those learners, and I think it might be because of ADHD, so let me know if you guys have the same experience. I've always been one of those students where I will learn better from a teacher who makes a personal connection with me past just that teacher-student shallow relationship. And Jarv, what she did was she became a role model to students, and she would ask us questions about our days. I remember it was a theme for freshmen to be so scared of this class. I remember I was scared of that class too because she just had this power, and we all felt it. And she proved that she deserved that respect through incorporating these teaching styles for learning style diversity, and also just making those connections with students, making us know that she actually does care. Because if I don't feel like my instructor cares, I'm not going to learn anything. They have to care and put in as much effort as I'm putting into them. And I think that's a lost connection. I remember one time we were talking about whether or not the moon landing was real, you guys. And it definitely was not part of our lesson. And I definitely played a role in leading that conversation astray. But she was never angry about it. She encouraged us to lead the conversation ourselves. And I think this was really important to the neurodivergent students in her class, which was probably a lot of us. And I didn't even realize it, what she was doing for me, until right now, when I just looked up best teaching practices for adult ADHD. The first class I took with her was physics. So if you're cringing watching this, Jarv, I totally understand. But honestly, I feel like I'll kind of know more than I am expecting, because I already knew the word inertia, and I also know that there are 3 laws of physics, okay? And I feel like once you have that, you have a pretty good base. So, let's just look up inertia, purse, and car. According to Newton's first law, an object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. And I don't know if I said, but this is on physicsclassroom.com. The law of inertia is most commonly experienced when riding in cars and trucks. In fact, the tendency of moving objects to continue in motion is a common cause of a variety of transportation injuries. Oh, I don't want to talk about injuries. I'm scared of that. It's talking about passengers. No, I just wanted to talk about a purse. we're moving on. I don't like how aggressive that was. This looks better. When Naveen accelerates and this is on brainly.com. When Naveen accelerates or decelerates while driving, his purse falls on the floor in front of the passenger seat due to an unbalanced force acting upon it. This can be explained by Newton's first law of motion and the concept of inertia. Increasing the friction between the purse and the seat can help prevent. I don't care about preventing it. I just want to know why it's happening. Okay, because I know. Hold on, because it's saying an object in motion is in motion. Does that mean if I'm sitting in a car, I'm technically in motion? Okay, hold on. There's an explanation. Hold on. Let me just read the explanation before I get ahead of myself. When Naveen keeps his purse on the passenger seat while driving, it stays in place due to its inertia, which is the tendency of an object to resist changes in its motion. Hold on. What is inertia? Inertia is the natural tendency of objects to stay in motion and objects at rest to stay at rest. Okay. So, if the purse is on the passenger seat, is it in motion or is it stopped? Let's look at the Google AI overview. Inertia is the tendency for objects to resist changes in its state of motion. Yes, because it's either staying in motion or staying at rest. Okay. So then Newton's first law. Wait. When a car stops, the brakes act as an external force to slow the car down. Okay. So that object in motion is being acted on by an external force. However, the purse is not restrained by a seatbelt or other device, so it continues to move forward. Eventually, gravity causes the purse to drop to the floor. Oh, so seatbelts are a counteract external force to the passenger's inertia. In this case, the passenger is the purse. Wait, what is this? If you jump from a moving car, your body will continue moving in the direction of the vehicle until your feet hit the ground? What? Hold on. Because does that mean that when I jump out, so if I was driving 120 miles per hour and I jump out of my car, would my body be moving at 120 miles per hour until I hit the ground? Why am I asking you? You guys aren't going to answer me. I got to ask Google. Wait, what was my question? If I'm going 120 miles per hour and I jump out of a car, would my body be going 120? Okay. So the answer is no. If I jump out of a car going 120 miles per hour, my body would not be traveling at 120 miles per hour the entire time until I hit the ground. This is because of air resistance, which is going to make my speed quickly decrease, eventually reaching a terminal velocity. What is terminal velocity? Oh, wait, I feel like I know what that is. Does that mean like velocity of death? Again, with the death. Why is physics so scary? Terminal velocity is a steady speed achieved by an object freely falling through a gas or liquid. Oh, so it's just like how fast do we typically fall? Okay, I see. The moment... whoa. See, no, look, initial speed. The moment that I jump out of the car, my body would be initially traveling at 120 miles per hour, the same speed as the car. But as soon as I leave the car, the air resistance is going to begin acting on my body and slowing me down immediately. Okay, hold on. So if I'm in a car, am I moving at that speed? You're moving at the same speed as the car itself. Okay, so if the car is traveling 50 miles per hour, then I'm also moving 50 miles per hour? So then that means my purse or my water bottle is moving at 50 miles per hour. Okay. Okay, me and my water bottle are both moving at 50 miles per hour because I'm driving 50 miles per hour. However, I have a seatbelt in, which is acting as an external force on me. So as I press the brake and I start slowing down, my body is going to start moving forward. But the seatbelt has another force because an object in motion stays in motion and an object at rest stays at rest unless a force is acted upon it. So that's why the seatbelt is there. But my water bottle doesn't have a seatbelt, so it's still moving at 50 miles per hour even when I hit the brake. That's why it falls forward. Because of inertia. Oh my gosh. Guys, I get inertia. Okay. What are the other laws of physics? What are Newton's 3 laws? Newton's 3 laws of motion are law of inertia. An object at rest stays at rest, and an object in motion stays in motion with the same speed and direction unless acted upon. And then there's the law of acceleration. So the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Huh? What does that mean? This law explains how much an object will accelerate when a force is applied, with more force leading to greater acceleration and larger mass requiring more force to accelerate. Why didn't you just say that? The first definition made no sense. Like, just say what you mean. So that episode of SpongeBob where there's that really big boulder that they're trying to move. It's really big and it's really heavy, and they can't apply a large enough amount of force in order to move it. And then once they are moving it because they're driving it, that means they are applying enough force for its mass. The third law is the law of action and reaction. Oh, I remember this. It's for every action there's an equal and opposite reaction. So that's like is that the one thing with the balls that go back and forth? It's that little thing with the wrecking balls. Yeah. I just Googled Newton's third law toy. And I found it. It's apparently called Newton's cradle. Newton's cradle is a device usually made of metal that demonstrates the principles of conservation of momentum and conservation of energy in physics with swinging spheres. At the beginning of the episode, I was like, I have a bone to pick. And I'm sure you're all dying to know what it is. What the flip is potential energy? Okay. There's a formula. Why are there formulas? Huh? Oh. I just had a flashback. I remember having to write formulas in physics. And for some reason, a triangle stood for change in time. And then we had to do like algebra, but instead of solving for y, we had to solve for velocity or something. I was really bad at math, you guys. And so the fact that we had to do math and physics was not good for me. So I feel like I don't need to learn the formula. I just want to know what it is. Okay, potential energy is the stored energy in an object due to its position, properties, and forces acting upon it. How can you measure an object's potential stored energy if nothing is happening to it? Common types of potential energy include gravitational, elastic, magnetic, and electric. 4 common examples of potential energy include a skydiver waiting to jump from an airplane, a rubber band that has been stretched out between 2 fingers, water sitting behind a dam, and the energy in a battery. So all 4 of those examples are stored energy that has potential to do work upon its release. How do you measure potential energy? Okay. Oh, it's back to the formula. Okay, so if you're solving for gravitational potential energy, then you're going to take the mass of the object times the gravitational acceleration constant times the height above the ground. What is gravitational acceleration constant? Is that terminal velocity? Oh no, it's just like Earth's gravity. I remember we did like this game on the computers in class, and we had to drop like a paper and a rock and a tennis ball on the different planets of Earth. That was fun. Oh, okay. But the gravitational accelerational constant is talking about an object in free fall, but without air resistance. So it's not taking into account air resistance. Okay. Why not? But I thought air resistance was a thing. Like, I thought you had to take it into account. Okay, this is why I get confused in physics, because I feel like people are just doing what they want. Potential energy is measured in joules. You'll also need a reference point so that you can get the height. So if you were trying to measure the potential energy of a stretched out rubber band. Okay, how can you measure potential energy of stretched? Oh, so there's a different formula for each type of potential energy. So with a rubber band, that's talking about elastic potential energy. What is Hooke's law? Is this just what Hooke's law is? Hooke's law is an empirical law that states that the force needed to extend or compress a spring by some distance scales linearly with respect. Hold on. I'm sorry, that's just not going to make any sense. Trying to determine the potential energy in a rubber band sounds really freaking hard. I think we're officially over my head. So elastic potential energy is when energy is stored in an object that is stretched or compressed due to elastic properties. When the deforming force is removed, the stored elastic potential energy is released. So when you let go of that stretched rubber band, that is going to release that energy and cause the object to return to its original state. Wait, let's go to Google Images. Looks like they have some diagrams. Okay, so a spring. Think about a spring in its normal state. It has zero elastic potential energy. But then you stretch the spring and it has elastic potential energy. And if you compress the spring, then it'll have elastic potential energy. If you are stretching or compressing, once you let go of it, that potential energy is released. So it's not doing anything yet, but it's about to do something. Okay. I think that's enough for me. It's been about 45 minutes of me doing this, and that's about how long physics class was in high school. I want to know what your guys' favorite teachers were like. What kind of teaching techniques did they use? And why did you feel like it was beneficial to your ADHD?